Well, we didn't get as far as I wanted to in the last video. We were rudely interrupted by me having to make some milk and what else was I doing? Oh yeah, balloon modelling. Hopefully you learned something from that, but we need to press on as quickly as we can here, otherwise we're never going to get this booklet done. So we ended up on this page and we were just talking ourselves through the steps for kind of type 4 factorising, okay? Really quickly on the next page, I make it page 9, if you're not including number in the first page, the title page, this is page 9. Alright, what are we going to say about this one? Nothing much to say. Again though, what I will pick out on all these questions, you can see it here, but also if I move this over, you can see it here. Little 1 marker at the start, okay? Basically where they ask you to prove the quadratic given some information. However, don't worry about it, because if you can't do it or you fail to do it, it's 1 mark in the end, okay? And the whole point of them giving you the quadratic is that even if you can't do it, you can still go on and do the solving bit, the factorising and the working out what it is. So quickly for this one, all we've got here is 3 slabs, and the total area being 7. The area of slab 1 is x times x squared. The area of slab 2 is x times x squared. The area of slab 3 is 1 times x plus 1. Again, you could write it down in brackets, I suppose, 1 times x plus 1, and which is just 1 times that and 1 times that, which is just x plus 1. So the total area is written there, x squared plus x plus 1, but we know that's equal to 7. A little bit of simplifying and moving that 7 over gets you the equation you need, but much more importantly, the big marks. Here they come, okay? Again, multiply the first number, the number before the x squared, by the last number. 2 times minus 6 is minus 12. Look for a pair of numbers that will multiply to give that minus 12, but will also add or take away to give the number before the x. In this case, the number before the x is actually plus, and you can see I've written it in there, plus 1. Just be careful, if there isn't a number there, you realise that is plus, and it's got to be plus. Different thing to minus 1. So my combo I've gone for is 3 times 4 to give me the 12 I need. Yes, it's negative, but that just works when we look at this because it's plus 1, I've gone for 4 minus 3. If the 4 is positive and the 3 is minus 3 negative, that's where I get my minus 12 from. So my plus 4 minus 3 this time is used to split up that plus 1 into plus 4 minus 3. Little line down the middle. 2 bits of factorising. Again, be careful with negatives here. If there's a negative in one or both of these, normally that negative comes out. So whereas just taking the 3 out of the bracket here, I'm actually taking minus 3 out. That normally marries up those brackets. There we go. And I've said here either this bracket is 0 or this bracket is 0 because I'm asked to solve the equation, giving me 2 answers. However, it does say justify any decisions that you make. Well, the decision I've made is that only this answer is possible. Because x length represents a length of and width of a square here and kind of the length of a rectangle there, plus 1, it's impossible to have an answer minus 2. I'm not going to be saying, oh, the length of this rectangle is minus 2, just doesn't make sense. So the only answer that makes sense is this one, and I've written positive answer taken to be x, okay? Quick look at the bottom. Okay, different type of thing, but again, we're not asked to solve, we're not asked to factorise, in fact, we're asked to simplify. But when you look at it, you've got a quadratic divided by some other kind of expression here. Anytime I see a quadratic, the alarm bells are going, hang on, I probably need to factorise this, particularly in paper 1. There's an alternative question in paper 2 we'll look at later, but I'm looking, there's a type 4 quadratic to be factorised. This bottom one here, not a difference of 2 squares, not a quadratic. I could probably do a bit of type 1 factorising. Okay, here's me factorising the top using this horrible method, and here's me factorising the bottom, just taking the 4 out, okay? So this then being my top factorised and this being my bottom, I've written as this divided by this, as it was there, okay? Notice then that I've got the same bracket when I factorise the top as what I've got factorised in the bottom. Cancel those, and what's left written as my answer. Really quickly on. Same sort of thing, I guess, okay? Now that I've done this, I'm starting to question myself whether I've got it right. Okay. The 1 mark, again, not a problem. This one was, use a little formula for what the height above the ground is of a ball thrown up. So the height is equal to this, and it kind of says, when the height is 4, prove this. Well, all I've done is put a 4 instead of h. Okay. H equals 4, I've written there. That's what I've written there. But then I've spotted, hang on a minute, in the answer they've given me, the 5t squared is positive, not negative. the plus 8t that there is actually minus 8t. So what they've actually done is they've moved all these things this way to make that positive, that negative. The 4 that is there instead of h, when I take that 1 over as minus 1, becomes 4 take away 1, which gives you the 3 that you need. But even if we don't get that 1 mark, who cares? Right? Who cares? The big money is here. Can I now factorise this and go on and solve it to get myself 2 answers for t? Well, here's the process again. This one was a bit nasty because, yeah, 2 numbers the times to give 15. 1 times 15, 3 times 5. How can I make minus 8 with those? Well, both would have to be negative. Okay? Minus 3, minus 5. So I've used that split then on the minus 8. Minus 3, minus 5. Lined in the middle. Factorise the first one. Again, what I said earlier, normally if one or both of these are negative, you would take the negative out. The other thing I thought was dodgy here is there's no number that goes into 5 or 3. So the only thing I could actually take out here is a 1. But I've taken out minus 1. And then it takes a little bit of thinking. Minus 1 times what would give me minus 5t? Well, it would be minus 1 times 5t. Put in the minus there. And then the minus 1 times minus 3 would give me the plus 3. Hence, I'm ensuring that that bracket is the same as that one. The 2 answers that I get are t minus 1 and 5t minus 3. That's for the factorising. But because these things equal 0, equal 0, equal 0, I'm able to go on and solve and say either that bracket is 0, so t is 1, or that bracket is 0, so t is minus 3 over to be plus 3, divide by 5, 3 over 5. Where I'm struggling with this a little bit, and maybe I need to read the question more and come back to it maybe in a later video, is what my interpretation here. I think I was hoping that one of these would be negative, because there's no such thing as negative time. So I could go on and say, like in the shape question, I'll take my positive answer. But both have come out to be positive. So I am struggling to see which one of those I would take. Maybe my interpretation here is that, hang on a minute. Potentially, but let me have a think about this and come back to it. Maybe it reaches a height of 4 meters twice. Right? So if you throw it from 1 meter and you throw it up in the air, it first gets there at 3/5 of a second. But any ball that comes up is going to come back down. So potentially, it went on its way back down, it gets there again at 1 second. So that is on the way up, and this one is on the way down. Interesting. Didn't like that, but it kind of came to me there at the very end. So you've really got to think about answers. When you've got 2 answers, the 2 answers make sense. Normally it's the minus one doesn't, the positive one does. But if they're both positive like that, I guess in that question they both kind of make sense. Anyway, moving on. Another chance for you to have a look at simplifying with using factorising to simplify, okay? But with a difference of 2 squares on the top and a type 4 on the bottom. Again, run that method. Hopefully you get something then that's on the top, that's also on the bottom, that cancels out. Hit pause. More and more of the same coming up, okay? Just more factorising. Again, ask yourself the questions. Is it a quadratic? No, because it's got the x squared but doesn't have x's. Is it a difference of 2 squares? Well, x squared is x times x, and 64 is 8 times 8, and it's a minus in the middle. So yes, it is. The 2 brackets being x plus 8 and x minus 8. Another simplifying one. Apologies, I haven't even given you the workings out yet. I just didn't think there was enough room. Having said that, the top has already been factorised in part 1, so we know that that is x plus 8. X minus 8, that's nicer then. The bottom will need factorising type 4. Hopefully when you use the method you get that answer, and then you can see, good news, we've got something that cancels from the top and bottom. Again, bit more factorising. Is it a quadratic? No. Is it a difference of 2 squares? Yes. The first one is 60 times 60, and then the 100 is 10 times 10. And my answer's there. Factorise, difference of 2 squares again, and then the bottom one you've got a type 3, an easy quadratic. Okay, find 2 numbers that times to give 6 that add to give 5. I've found 2 and 3. Times to give 6, add to give 5, so x plus 2, x plus 3 is that. Bottom one is a type 1, which is your single bracket. Take the 3 out, you're left with that, and again, something cancels there. Okay, algebraic fractions. Let's pull this up really quickly. Okay. This is slightly different to simplifying fractions that we've done with quadratics and factorising the top and bottom. This is when we've got two separate fractions, okay, with either an add or a take away in the middle. Now, ignore these lines a minute. I shouldn't have pre-drawn them on, okay? But you can take two fractions and make them into one fraction, okay, by doing this times this, take away, or if that was add, but in this case, take away this times this, okay? And then on the bottom of the fraction is this times this. So you can see me connecting those two, and then on the bottom, connecting those two. Okay, what does that look like then when I write it out? 4 times that, if it isn't in a bracket, put it in a bracket, okay? There. Minus x times that, put that in a bracket again, over that times that. You've got a single bracket, another single bracket, and then a double bracket to expand. Simplify as much as you can. Job done. Okay? Again, what does that look like on a paper? We're on to page 12 for me. And here we go. Let's have a look at it. That times that is written there. Minus that times that. I put careful, make sure that minus, because that minus kind of attaches itself onto that 2x. So when you're expanding this bracket, it's minus 2x times this and minus 2x times this. Think about a minus times a plus being a minus, or a minus times a minus being a plus. And then on the bottom, I've used my smiley face or foil. This times this, this times this, this times this, and this times this. There it all is. How did this then simplify? Well, on the top, I noticed I had 6x squared minus 6x squared, so they cancelled out. But I also had 21x minus, there's the minus, minus 4x. Okay, which gave me 17x on the top. On the bottom, I got 6x squared, then I got plus 4x and plus 21x, which I've combined to make plus 25x and 14. Remember, you can't combine x squareds with x's when you're adding, they are different terms. Another one, exactly the same. This times this, take away this times this, expand the two single brackets, over this times this, expand the double bracket, simplify everything, cancel out things that go, etc., etc. And whatever you're left with, Okay? Can you see that one? Sorry, I paused, probably didn't give you a chance. Now, another one exactly the same. Okay, yeah, nothing to say that. In fact, probably easier because you've got a plus this time, so it's this times this plus this times this, which probably reduces the chance of making a mistake because of that being negative, you'd like to think. And another one in the middle, the same. Again, can I just pick up on the wording because I haven't said it? All 4 that we've looked at so far have said express this as a single fraction in its simplest form. So you combine them together by doing this kind of cross multiplying thing. This times this times this, and then this times this on the bottom, and simplify it as much as you can. Nice, easy 4 marks. Now, to end this video, then we're going to have to have a part 4, the joys. Okay. To end this video, we're going to look at how we can use this technique. If it doesn't say express as a single fraction, but if it says solve, the only difference being, looks pretty much the same, but at the end, I've got this fraction, add this fraction, but I've got an equals something, okay? But you're going to pretend that that isn't there, okay? You're going to look at this just like you've looked at the ones above, like this one, okay? You're going to do this times this times this, over this times this, just like we've done, okay? This is exactly what I've done here. 3 times that. Notice again, if you've got a couple of things you're timesing by, it's often better to think about these things being in brackets. 3 times that, plus 2 times that, over 2 times 3, but 2 times 3 is 6. But there's that slight difference, equals 31 over 6, which is what I've got here. Now, on this slide here, I've just expanded these brackets, not a problem for you. But another thing I'm going to do is this, because I've got an equals that I didn't have when I was looking at these types of questions, what I was dividing by 6, I can move up as a times. So I've got 31 over 6 times 6, okay? When I simplify this, I get 22 and plus 3x minus 6x minus 3x, but equal to 31 divided by 6 times 6. Well, no point timesing by 6 and dividing by 6. You're going to end up with just 31. So you end up with this little equation here. This is not a quadratic. This is a linear equation. It's got x's in it. So it's solved by putting numbers one side and x's the other. Move it up a little bit more for you. Okay, so what I've decided to do is, because my subject, the x that I want to find the value of is negative, okay, minus 3x, I've moved that over to become positive 3x, but in return, the plus 31 I'm bringing over as minus 31. 22 take away 31 is minus 9, and then he is positive 3x. But if that's 3 times x, I guess the opposite of times it by 3 is to divide by 3, and minus 9 divided by 3 tells you that x is minus 3 in that one. Now let's quickly have a look at the bottom of page 14 at this one. Again, something I did notice, if you compare this to the kind of the ones that we've done already, the expressing as a single fraction, 4 marks. This one down the bottom of page 13, which you can't see, I know on the video at the moment, but little linear equation comes out from this one. 4 marks, 5 marks here, 7. Right, let's get to grips with why this is 7, then let's have a look what goes on here. Again, I start by doing this times this, okay, putting that in a bracket, plus this times this, over this times this, n plus 1 times n plus 3, but equal to 6. Now, if that wasn't there, I'd probably go through the process now of expanding everything, which is exactly what I'm going to do, but I'm going to kind of use shortcuts, so I'm not here forever, okay? So we're going to end up with 20n here, okay? 20n plus 60 plus 5n squared plus 5n, okay? Over, expand those and simplify, you'll get n squared plus 4n plus 3 equal to 6, okay? Down here, the opposite of dividing by 6 was to take that up and times by 6. Why is this so much harder? Well, this time I'm not dividing by 6, I'm dividing by this mess. But the opposite of dividing by this mess, because I'm solving, I don't want a fraction, I need that up there as a times, okay? So simplifying the top as well, I end up with 5n squared plus that 25n plus 60 equals 6 times all of this. Moved up there. Okay, expand that. Nothing doing this side a minute. So just 6 times them all. 6n squared plus 24n plus 18. Okay, now I've got a quadratic here and a quadratic here, but in order to solve this, I guess I just need a quadratic one side. So what I've decided is, instead of moving that 6n squared over there, so I have 5n squared minus 6, so I'd have negative n squared, not what I want. I'm going to move him over there. That means I'm also moving him and him. I'll leave nothing this side. 6 minus 5 is n squared, okay? 24n minus 25n will give me minus 1n, minus n. And 18 take away 60, when that comes over as minus 60, will give me minus 42. And what I'm left with is a type 3 quadratic, okay, type 3 quadratic. Now, you go through that method, okay, 2 numbers that times to give minus 42, that add or take away to give minus 1, and again, straight in them with 6 times 7, 6 take away 7, will give me minus 1. So, my 2 brackets, x plus 6, is much nicer. Actually, I was expected to have to do a type 4 because of this amount of marks, but hey, I don't have to. So my 2 answers, either x plus 6 is 0, so x equals minus 6, or x minus 7 is 0, so x equals 7. Hopefully you can see those. I'll scroll up a little bit, okay? You follow through that method, okay? And then you got the same here. Again, here, because there's numbers on the bottom, you end up kind of with a linear equation to solve, okay? Whereas here, hopefully you can get all that in. There we are, just about. Because there's kind of these horrible bits of algebra that are brackets, you've got all this to do. You've got to take that up there like we've done. There's just loads to do. And in fact, this time, even harder than what we've just done. The quadratic that you're left with is a type 4. So there's kind of an extra process. I'm surprised that this, in fact, I've written that in there. That will not be worth the same as him. Okay, he'd be 7 marks, but this guy, because of the type 4, he's going to be 8 marks. Join me for the final bit of this video. which will be part 4, and we'll go through the last couple of topics on here. Stick with me, we're nearly there.